Hey everyone, here's another story problem or application problem that we had possibly on the test. But excuse me for having this be so small, but hopefully you can read this. But a car went 346 miles in 6 hours, traveling part of the time at 49 miles per hour and part of the time at 69 miles per hour. How long did the car travel at each speed? So let's kind of write this out. We're going to say this is total. And the total was 346 miles. And then time was 6 hours. All right, so you know you drove a little bit at 49 miles per hour. And we drove a little bit at 69 miles per hour. So really this problem, the typical thing that students want to do is they want to try and say, because there's two different times here, there's a time at 49 miles per hour and there's a time at 69 miles per hour. Most of the time, the most common mistake in this problem is students want to say, all right, I'm going to say x equals time at 49 mph. And then a lot of times the students will say, okay, well, this is going to be probably a different time. Could be the same time, but they'll say y equals time at 69 miles per hour. Now, the problem with that is if x and y are different things and we only have one equation, we can't solve that equation for x and get a number. We can solve it and get an expression. And we can't solve it and get a number for y. We'll get an expression as well. So that puts us kind of in a bind when we decide that there's actually two different variables in the same equation. So this is not the right way to start this problem. So instead of writing y as a separate variable, we want to actually write y in terms of the variable x. So we know x is a time at 49 miles per hour. We want to write y in terms of x, so that we can represent y with an expression which has x in it. Basically what I'm asking you is, okay, let's say if the total time is 6 hours, let's say we travel 2 hours at 49 miles per hour. That means we would have 4 hours at 69, because 2 and 4 gives you 6. If it's 3 at 49, then it's 3 at 69. 3 and 3 gives you 6. If it's 4 at 49 and 2 at 69, 4 and 2 would give you 6. If it's 5 at 49, and then it would be 1 at 69. Each time I'm taking really 6 minus 2 to give me the 4, then 6 minus 3 to give me 3, 6 minus 4 to give me the 2, and then 6 minus 5 to give me the 1. So really the whole time, instead of saying y equals, I want to say that this is really the total time minus x. Total time minus the time at 49 miles per hour is obviously going to give me the time at 69 miles per hour. So now I have an expression written in terms of x. So now I have two different expressions with terms x. I can actually write an equation from that. So what I'll do is I'll say, okay, 49 miles per hour times the time, which is x, plus 69 miles per hour times 6 minus x, which is our time over there, is going to have to give us, well, let's see, speed times time is obviously going to give you a distance. Speed times time is going to give you a distance. So I better write this is our total distance, 346 miles. And now I can solve this equation because I got one variable in the equation. Distribute, and I get 49x plus, let's see here, 69 times 6. That's 414. Minus 69x equals 346. Combine like terms, you get negative 20x plus 414 equals 346. Subtract the 414 over, and you get negative 20x equals negative 68. Divide by negative 20, you get x equals negative 68 over negative 20, which equals 3.4. So that's 3.4 hours. And that's for x. So if it's 3.4 hours for x, then for this equation up here, so 3.4 hours for x, which is 49 miles per hour. So 3.4 hours, I would interpret that at 49 mph. Then that would mean I take 6 minus that, which would give 2.6 hours at 69 mph. Hopefully that makes sense to you.